Hey everybody, welcome. So I'm really excited to tell you about this today. This is going to be not so much an ordinary tutorial, rather an introduction to a brand new feature in Max that got released yesterday, November 1st with Max 8.5, something called a Rainbow. Rainbow is something that I know that Cycling74 has been working on for literally years. I've been lucky to be playing around with it for the last few months or so. I'll tell you a little bit about it. So what is it? It's a patching environment inside of Max, a little bit like Gen. And when I say that, I mean that basically we have rainbow patches that live inside of Max patches. They look like Max patches, but they're not. The objects that you see here are all rainbow objects. Many of them share the same names as Max objects, and many of them work just like Max objects, but technically they aren't. And the reason that this is a separate thing from regular Max is that this type of patcher, rainbow patcher, has a special power, which is to be able to take this patch and export it to many different locations or many different forms. This is the power of Rainbow, and this is the thing that Cycling74 has done. They've made it possible for me to make a patch in Max and export it as JavaScript that I can use on the web. I could use on a website. I can export it as a plugin that I can run in my DAW, including one that isn't Ableton, right? I can actually create Max externals, and I'll show you one of those in a little bit, really, really easily. I can also export the code, the raw code for this Rainbow patcher in C++, which is the default digital signal processing language, and is what you would need if you wanted to make, say, a mobile app that could produce or process sound. C++ is also the sort of the core of both the audio plugins as well as the Max externals. So if you were somebody who, are, let's say, making Max for live devices, and you always wanted to make VSTs so that people could use your devices outside of Ableton Live, that's actually possible now. Because if you work in Rainbow, you don't have to know C++, but you can still make plugins, which is pretty amazing. So while we're looking at this patch, which is, by the way, just a pretty simple pattern generator, it works a little bit like subdiv. It takes a phaser in, it subdivides it, and then it only lets certain of those subdivided phasers through depending on the selections that you make. And all I'm doing here is just sending in a message like so. So let's talk about a few things. Number one, what Rainbow has in common with Max patches is a lot of the same objects, meaning objects with the same names and the same basic capabilities. You can also work with both event type data that travel over these gray patch cords, or with signal data that flows over the yellow and black patch cords through the tilde objects. There's no jitter in Rainbow, and you can only work when we're talking about the event objects with floats and with lists of floats. So there's no symbols, and integers always get converted into floating point numbers in Rainbow, and I'll show an example of sort of what the implications of that are later on. On top of all of that, you have a lot of features that are available in Max that are also available inside of Rainbow. So for example, print works, which if you've worked in Gen before, which is what many people would use if they wanted to export their code to C++, you can't print anything in Gen. You also can't use scopes or other user interface objects in Gen, but you can in Rainbow. So I have scopes here showing my waveforms. I also have a toggle here that converts my phasers into gates. There are some minor differences between some of the Max objects and the Rainbow objects. One, for example, is that the ZL objects are actually called list in Rainbow. I think in Max now you can say list.enth and it's the same thing as zl.enth, but in Rainbow you can't say zl.enth or zl.size. But otherwise, there are many objects that do the exact same thing, like list funnel works exactly the same way in Rainbow as it does in Max. There are also some Rainbow specific objects that you won't see on the Max side. An example is this data object, which is kind of like a specific type of buffer that's very useful within Rainbow, and we'll definitely talk about in future videos. You can see here that we have specific types of inlets and outlets that work in Rainbow, and these are type specific. So for example, this is a signal inlet. If I wanted to create a second one that was designed to receive event style data, I could do that. And there are a few different ways to communicate to and from the Rainbow Patcher. So the most obvious one are the inlets and outlets. And then the other one is this import object, which is sort of a virtual inlet, I guess you could say, for event style data. And then the other one is param, which we'll talk about in just a little bit. Import is kind of your basic way of defining a message that the patch is able to receive. So in this particular case, I'm saying prepend message pattern. And what that will do is tell the Rainbow Patcher to look for an import object that is named pattern, and then the data that I send in there will flow on into the patch. So if I go into my console here, and actually I'll open it over here, and I click some buttons, you can see I'm printing actually from inside of the Rainbow patch the data that I'm sending in there. If I wanted to, I could achieve the exact same thing by just creating an inlet into and replacing the import object with that, and then getting rid of this prefix and connecting, of course, the patch cord to the second inlet. And the same thing will happen. Now you may have noticed when I made this change to the Rainbow Patcher, so if I go back to saying import pattern, a few things are going to happen when I hit enter here. So one is you're going to see a blue bar down here at the end of the window start to work, and you'll see some sort of animations down here. And if you're looking at the main Max patch, you'll also see a kind of gray status bar make its way across the Rainbow object. So I'm going to hit enter now. And you can see all those things happen. So it says compiling, generating down here, and we get that status bar. In Rainbow, anytime you make a change to your patch, that change needs to be recompiled. So this is, in a way, sort of a disadvantage of Rainbow. If you have a pretty big patch, it's going to need to go through that compiling process every time you make any change. They have included this option that allows you to disable auto-compile, which means if I make a change, it doesn't automatically try to compile it. And then if I make a change, so let's go back to in2, this change is actually not reflected yet in the function of the patch until I manually compile it by clicking this little hammer, right? Most of the time I'm finding that leaving the auto compile on is totally fine. And you can just patch away, and sometimes you have to wait a little bit for it to compile in order for those changes to take effect. But if you find that as you're working with this, that it's kind of trying to constantly compile as you're making changes and it's slowing things down, you can just turn that off and compile manually. Okay, so let's talk a little bit more about communicating. Actually, two things. So the first is communicating with your Rainbow patch. So we already talked about inlets as well as this import object. But another really important one that I alluded to earlier is param. So param is a way basically to define attributes that the Rainbow object has that can be configured using the Adder UI object like I have here. And also we can just use normal messages. So I could say carrier freak 10 if I wanted to. And I could send that message in, and it's going to update that value, right? So it works very much like, if I have a subdiv object as an example. And let's just put a phaser in, 0.5. And I say div 8. What I'm doing is, updating the div parameter of the subdiv object. So it's basically exactly the same. This param object is how you define an attribute of a rainbow patcher. And these parameters carry along, they follow when you export the rainbow patcher to these various export targets. So if you have JavaScript or if you have Max external, these parameters are exposed as attributes or parameters that users can control when they're actually using that code or that device. You can see here in the parameter object that there's a couple of arguments as well as attributes defined. So the first is the name, the next is the default value. Then, and then in this case, I'm defining a range, minimum and maximum values that this particular parameter is allowed to have. There's actually a lot of other options that you have here. So like one thing you could do, for example, is define the steps attribute. So I could say 1001 steps, which is going to basically mean that the across this 0 to 1000 range, there are 101 unique values, which means that I'll basically get integers. So 0, 1, 2, 3, 4, 5, etc. There's also a ton of other features, and we'll probably do a whole nother video on param object. And there's a bunch of documentation on Cycling 74's website, as well as within the help patcher, which, by the way, all the rainbow patches objects have help patchers, which is pretty cool, as well as reference. So it's really a lot like Max. And as you could see, as I mentioned, the adder UI object works with those params. And when I export my rainbow patch to an external, like I've done here, if I double click this, nothing happens because this is just a Max object running natively in Max. If I come over here and I go to this attributes menu, you can see I can see those parameters and I can create new adder UI objects if I want to. If I go into the inspector, you can also see those parameters here. They're kind of hidden behind my head, but they're over here behind my head. These are attributes just like you would see in any Max object. So in this particular case, I have a rainbow patch here on the left, which is a saved rainbow patch. So I've made this patch and saved it as pdm.amlfo.rainbowpat. And then I exported it as well to external as pdm.amlfo tilde. It automatically adds the tilde if the patch has audio processing objects included. So you don't have to give it that name. It does that automatically. And doing that export is literally as easy as coming over here and hitting this button down here, export to selected target. And it takes about 3 minutes for a simple patch like this, and it creates an external for you. The way that it actually does that is by like talking to a server that Cycling 74 maintains that's somewhere in the cloud that actually handles the compiling and building of that object and sends it back to you, which is pretty amazing. So you do have to be connected to the internet in order to do these export targets, but it's not too much of an obstacle. One other incredible thing with particularly the Max external export is that you can create the MC wrapper, which basically means that the external can be MC enabled, can work with MC. So down here, I have an instantiation of this same pdm.amlfo tilde external, but in MC version with 3 channels. And you can see I'm producing 3 different waveforms here that have different settings. So pretty amazing. And it literally is as easy as just ticking this box, and there's nothing more that you need to do in order to have MC. So we talked about named rainbow patchers, and it's also impossible to use named rainbow patchers inside of other rainbow patches. So in this case, I have a P, and I'm saying at file, seek event modifier output, which is the name of a rainbow patcher. And I can open that and see that here. It's also possible to host gen patchers within rainbow patchers. So in this particular example, which comes from the Rainbow Synth building blocks package, which you can find in the package manager. I definitely recommend searching for that, Rainbow Synth building blocks. They have a gen patch that lives inside of the Rainbow patch that does additive synthesis. So one of the huge benefits here of Rainbow, even for people that are already very experienced with gen, and perhaps are even already using it to export C++ code, is that that process just becomes smoother, right? You can have your code in gen exactly as you did before. You don't have to make any changes to the gen patch. That can live within the Rainbow patch, and then you just define inlets and outlets and parameters in Rainbow. If you want to have extra patching, perhaps event stuff, whatever, inside of Rainbow, you totally can do that, and then you can export it. In fact, this one, I think in particular, you could probably just export it as a VST, and it would be usable in any DAW environment, which is pretty amazing. By the way, this particular one I think is pretty fun, and it's in this sort of vein of we've been talking about with a lot of these videos of different ways of producing patterns, basically musical patterns. So the idea here is we have two phasers, each of which is connected to a what object. So it's just giving us a series of pulses each time those phasers reset. And I'm using R slider here to control the frequencies of each of those phasers. So the one on the right is controlled by the lower range value here, and the one on the left is the upper range value. And basically what happens is this Rainbow patch that I've written works almost exactly like the Max object one bang, which does not let bangs through from the first inlet unless the bang on the right has been banged. So if I click this, I'm going to get nothing until I click this, and then I get something. And then if I click again, I get nothing until I click this again. So it's using that same concept where pulses from the what object that we receive here on the left, and you can see those up here on the top, are not allowed through until there has been a basically gate opening pulse from the what on the right, which you can see here. And then the third thing here is the result. And then the fourth thing is actually just a different way of displaying that same result as either a gate, so like an on and off, or as a running count of the number of events. So maybe we'll do a video at some point to kind of dive into this one, because I think it's a cool way to create patterns through sort of the interaction of two patterns. Another thing that is incredible about Rainbow and an amazing improvement is the way that it handles polyphony. Anybody who has used Max to build things like synths and wanted them to be polyphonic is familiar with the poly tilde object, which acts as this kind of wrapper around a Max abstraction that you write. So say I had a Max patch that I called mysynth.maxpat. And I basically define a poly object, I tell it which abstraction to refer to, and then I give it a number of voices that this synth has. And it works, but it honestly is a bit of a pain. I even find it pretty frustrating sometimes to work with this. What the team has done with Rainbow to handle polyphony is really, really nice. In this particular example, literally all I had to do was make a Rainbow patch, normally exactly how I would if I wanted this to be monophonic, and then just use this attribute at polyphony 8, and now I have 8 voices. So let's hear it. Now, there is a ton of flexibility in how polyphony is handled by Rainbow. This is kind of the simplest example, and there's pretty good documentation at rainbow.cycling74.com on this. So you can really customize how the Rainbow patch handles note events and handles polyphony or voices is the right way to say it in Rainbow. But I'm finding that in most cases, it's as simple as just creating a patch and doing at polyphony whatever. It works in conjunction with, very often, with MIDI objects. So here I have a node in, which functions very, very much like the node in object in Max. And you can see that when I create this node in object, it's actually created a MIDI input over here on the right for me. And I'm just passing the output of a MIDI format object as if I were going into a MIDI out, right? If I wanted to send MIDI to somewhere outside of Max, I would set it up like this. I kind of treat the rainbow patch like it's its own MIDI destination, and I just send the output of a MIDI format object to it. It's also possible, I haven't done it here, but it is possible for me to expose, we have this attribute, expose voice params, which makes it possible for us to actually control each of these attributes that are used to sort of define how this weird sampler is working, to have those attributes be unique for each polyphonic voice. So if I tick this, it's going to compile. And you can see now I have the ability to change the sequencer parameters for every voice of this device, which is pretty incredible. In this case, I'm going to keep things simple. This is also a good opportunity to talk just a little bit about how we can handle samples in Rainbow, which we'll definitely talk more about. But basically, I have a buffer here, and I dropped a sample in there, which you can see here. You could also see it in the waveform object here. And then inside the Rainbow patcher, I also have a buffer, which I've included just because I need to get the length within this patch of the buffer in samples. So anytime I add a new sample, it's going to change the length of the buffer. And I just need to know what that is. And then you can see that I've referred to that same buffer using a wave tilde object, which works very much like its counterpart in Max, where if I send a value between 0 and 1, it's going to play back that, the sound that's in that buffer at that position. So the handling of samples and sort of those kinds of things is really flexible in Rainbow. This is a simple example where we just have a buffer basically that's shared between the Rainbow patcher and its parent Max patch. But there are also other objects like the data object that you saw in one of the other Rainbow patches that doesn't communicate with the parent Max patch, and it has some special properties that make it useful in special situations, which we'll definitely talk about in the future. The final set of things I want to talk about is just helpful stuff for you to know as you dive into this. Hopefully you're running to Max to go do that now after this video. So the first is Rainbow doesn't work with the normal Max scheduler. A little bit like the JS object. So this is a really simple example that I've made here where inside the Rainbow patch, all we're doing is adding 3 to the input. And then on the left, I have the same thing just with normal Max objects. And the way that I have this patched, we're using a trigger object, which following Max's right to left sort of event ordering rules, we would expect that we'd get the 1 here to be sent out first into the Rainbow patch, 3 to be added to that, and then we would see the value 4 printed in the console. And then after that, we'd get the value 1 passed through the +3 here, and then printed, then that's printed in the console. If I do that, you see we actually get the Max event first and the Rainbow event second. And that's because Rainbow kind of operates in its own event processing thread. If you're passing signals through Rainbow, you don't have to worry about this issue. You're not going to get anything unexpected in terms of the order in which things happen. But if you're working with events, you're sending messages or floating point numbers around, just be aware of this. Generally, you're not going to want to use a Rainbow patch in any kind of complicated flow of Max events. Like if you got an Uzi in there somewhere, you're not going to want to hit the Rainbow patch with an Uzi typically. Another thing to call out, which I mentioned earlier, is that in Rainbow, all numbers are floating point numbers. So in this example, I'm just dividing by 3 with no dot, right? No period after the 3. In Max, if we do that, we're doing integer division. So if I send the value of 1 here, or if I send, let's say, 5, I'm going to get 1 because it's doing integer division when I don't use the decimal point. Where I do include the decimal point, I get 1.667. On the Rainbow side, even though I have no decimal point, it still gives me the floating point result because all numbers inside of Rainbow are floats. The last thing I'll talk about here is just some, I guess, guidance on how to think about when Rainbow is useful and when other things are useful. And I've broken down here to kind of an incomplete list of the different ways to make stuff in Max. So the first is your standard Max MSP jitter objects. So there's many reasons why you might want to use this, and this is obviously still going to be the default for most of us most of the time. But if you want to, do normal Max stuff, if you want to really easily be able to debug and monitor things, if you don't want to have to worry about the compiling that needs to happen every time you change a Rainbow patch, if you want to use jitter, which doesn't work inside of Rainbow at all, because Rainbow is really, I think, designed for an audio kind of use case. If you want things like B-patchers, which aren't currently supported inside of Rainbow, and if you want to use things like the pattern system. So Rainbow, we can talk definitely more about this in the future. The param capability in Rainbow is really awesome, but it does not integrate with the pattern system that is used in Max to create presets, which we talked about in another video, which I'll put the link up above, and which is really the best way to handle things like presets. So if you want to have presets with a Rainbow patch, usually what you end up doing is kind of having the Rainbow patch sit in the middle around kind of a circle of pattern objects that are used to kind of handle the parameter management. However, if you are looking to obviously export things to all the various targets, and you want the easy polyphony and support for MPE, Rainbow also makes MPE very easily, MIDI polyphonic expression. And you also want to use this granular object that I haven't even referred to. We'll talk about it in the future, but there's an amazing granular synthesis object inside of Rainbow. Use Rainbow, right? Gen, if you're writing hardcore DSP code and you need the single sample level accuracy that Gen supports, use Gen. I think a lot of people that use Gen now are going to be running Gen inside of Rainbow. And that's Gen tilde. Regular old Gen, probably not used all that much by that many people, but if you're doing a ton of math with Max events, it's good. And then JavaScript, I would sort of add as a separate category here. If you're doing the kinds of things that JS is good at, right? So working with lots and lots of lists, working with dictionaries, working with jitter matrices, adding and removing data from either matrices or buffers, as well as scripting within Max, so actually manipulating the Max patch itself. JS is really good for those things. You can't really do any of that inside of Rainbow. So that's a kind of a quick overview. I think there's probably a lot of details missing there, but just how to think about this. When to use Rainbow, it's really when you want that export capability. When you're thinking about building something that you're going to be able to encapsulate as either a Max external or export to a VST or what have you. One thing that I've been finding is incredibly useful and sort of surprisingly useful about Rainbow is that it is kind of changing how I think. It's forcing me to really think about how to create a patch that is whose functions are very well defined, whose capabilities are very well defined, and whose parameters are very well defined, and which communicates with the outside world in all the ways that I would want it to. And that's because a lot of the time when I'm working with Rainbow, I'm thinking about that eventual point at which I'm going to export that patch to external, and I'm not going to be able to get inside of it, right? So a lot of the patches that I've made in RNBO, what I'll end up doing is exporting them to an external. And you will hear a lot more about this because I'm actually building a package right now. And then I use those externals in my Max patches. The result is my patches run a lot better because I have a lot less Max code actually being executed. The externals run way more efficiently on the CPU. And so the fact of sort of making the decision to take what in the past for me would have been abstractions and make them externals is actually improving me as a Max patcher and forcing me basically to build patches, to build externals that that interact very well with the rest of my system. So that's one of the things I've really learned is particularly valuable about this. It just makes you think a little bit more intelligently about how you're patching. So I hope all of you get the chance to dive in here. If you have any questions on this video, post them down below. If you have any recommendations on what you want to hear next, post them down below, and we'll see you next time. Thanks.